Welcome to yet another episode of the NewSpace India podcast, a bi-weekly talk show that exclusively talks about India's space program. My guest today is Arup Dasgupta, who served in ISRO between 1970 and 2005 and retired as the Deputy Director of the Space Application Center in ISRO. Arup began his professional career in the Satellite Instructional Television Experiment, or the SITE experiment, which was the world's first direct-to-community TV broadcast experiment using the US ATS-6 satellite. He then moved on into remote sensing and was involved in the first experimental remote sensing satellite Bhaskara and later operational satellites IRS-1 through P6 ResourceSat. In this episode of the NewSpace India podcast, we explored the realm of remote sensing applications from a historical perspective and the current trajectory of its use within India and provide some future perspectives. Arup, welcome to the NewSpace India podcast. Thank you so much for taking time and doing this episode with me.
Thank you for having me, Narayan.
I saw your LinkedIn profile and it said that you graduated sometime in 70 and then, early 70 you joined ISRO. So you have quite a long career, almost 50 years of knowledge of space-related activities. You must have a lot to share in terms of the transition of technology and how it has matured over time. I'm really looking forward to this episode in that regard. So one of the questions that I want to kick off this podcast episode with is, when you started your career in ISRO, did you see remote sensing as a sector that would come up, or were the early days of SITE experiment, was it just a transition? How was your beginnings?
Yeah, actually, after I graduated in electrical communication engineering, I got an opportunity to work in ISRO on the SITE project, and that was basically a communication project. And at that time, I really didn't know much about remote sensing. I knew a few people were talking about it, but I never paid much attention. But it was only around 1975-76 when Professor Yashpal, who was our director at that time, we had just finished SITE and I was kind of at a loose end. Professor Yashpal called me and said, Arup, why don't you consider switching over to remote sensing? And I was pretty taken aback. I said, I am a hardcore communication engineer, and what do I do with all these physicists and others? So he gave a big laugh and he said, Arup, you have been working on extension services under SITE, and that is what you need to now do for remote sensing. And that's how he pushed me into a unit which was then known as user cell. He made me a manager over there, and then from there on I started learning about remote sensing.
You talked about Professor Yashpal giving you this direction. So was this something that ISRO had come to know from other peers, as in other space agencies, that they were also taking a look into remote sensing and especially the societal applications of remote sensing, or was this something within ISRO that came up?
Yeah, actually, in fact, much later, I came across a quotation from Professor Vikram Sarabhai, and this is 1969, when we had the first conference on the peaceful use of outer space. This was in Vienna, and Dr. Sarabhai was the chair. And this is something very interesting which he said, and I think it has relevance to what your question is. He said, when we came to Vienna, we thought that the areas of most immediate practical application would be communications, meteorology, and navigation, in that order. But one of the most striking things to emerge has been the appreciation of the great potentiality of remote sensing devices. And then he goes on to say that, for example, in cartography, the benefit can be as much as 18:1. And then he goes on to say the time has come to interest meteorologists, hydrologists, surveyors, agriculture specialists, and other groups in such programs. So this was actually, what Vikram Sarabhai had almost, you can say, vision in 1969. And then it was actually turned into reality by creating a small group in Vikram Sarabhai Space Center in Trivandrum. At that time, of course, it was not known as VSSC, it was known as SSTC. And there was a small group created there in which he put in a few scientists like Professor Pisharuti, who is really known as the father of remote sensing in India, and then one Dr. T.A. Hariharan and Professor Praful Bhavsar, and a few others. And of course, then they moved to the physical research laboratory, and that's where the whole remote sensing activity started. And what they had done was that they actually, after seeing Vikram Sarabhai's interest and getting leads from him, they went to NASA, and from them they borrowed a couple of Hasselblad cameras, large format 70 cameras, and some film, because you needed the color infrared film, which was not available in India. And then they flew it on a helicopter over coconut palms in down south in Kerala. And the idea was to see whether they could detect those coconut palms which were affected by a disease called coconut wilt disease. And they found that there were many trees which had the disease, and the disease was actually manifest in the crown. And if you look at the tree from the ground level, you wouldn't know that this tree was affected. So this was the first example which they did of using remote sensing to detect crop disease.
Absolutely. I think that's a very important piece of history. So when you talked about this borrowing of the camera from NASA and flying this, the transition from doing something in airspace and then outer space is very different. And the challenges are, of course, extremely different as well, especially in terms of managing the electronics and the communication and so many other things. Was ISRO prepared for such a transition from just flying from a helicopter to then thinking of building a satellite? Were things like mirrors, sensors, all of them really available for this kind of transition?
Oh, yes. I mean, you see, just after this experiment, there was a small group created called Remote Sensing Division. At that time, Space Application Center had not been formed. We were just all separate divisions. And Remote Sensing and Meteorology Division was formed with Professor Pisharuti leading the group. And they continued to start working with aerial surveys. And of course, they bought the Hasselblad cameras and everything, and the film had to be imported. But at the same time, the very interesting thing that happened was that Landsat had been launched somewhere around, I think, 1971. I'm not very sure. And Landsat, at that time, the Landsat data was available only if you become a principal investigator. So I think one of the senior persons in ISRO, I think it was Professor Chitnis, or maybe it was Professor Pisharuti himself. They became the principal investigator, and we started getting data from NASA covering whole of India, and that was really an eye opener. And because we had this idea that it's useful for the country, so we started calling up people from different departments and even universities to show them what satellite imagery can do, and growing an interest in utilizing some of these kind of technologies. Parallelly, we started looking at what could be done with whatever little meager resources we had. And around that time, if you remember, we had launched a satellite called Aryabhatta. That was our first satellite. So it was quickly decided that we will now take Aryabhatta, the basic structure, and in that we are going to put a camera which was called a super Vidicon, and a couple of microwave radiometers. In fact, the microwave radiometers were a bit of an afterthought, because one of the persons here, Professor O.P.N. Kala, was very keen on trying that out. So Bhaskara 1, that was the first satellite it was made, and it was launched from Soviet Union. We had a big hiccup because one of the cameras failed to operate, and that failure was found to be due to arcing in the high voltage supply to the Vidicon camera due to outgassing. So the second camera was not switched on. We waited for, I think, about 5-6 months, and then when it was switched on, it started giving pictures. Now those pictures were just 1 kilometer resolution pictures, but they were fantastic, and the whole country was absolutely taken up by this. Even though Landsat was at that time 70 meters, and people would ask these kind of questions, that what can you do with a 1 kilometer data when you have a 70-meter resolution. But nevertheless, since we had done it, it was our effort, so we made a lot of effort to get people interested in this. And in parallel, and this is where the interesting thing happens, and in parallel a committee was set up, and Dr. Hariharan was in charge of the committee, and as far as I remember, Chandrasekhar was the member secretary, and they were tasked with finding out what can be a configuration of a remote sensing satellite. So they went into great detail on many of these technologies. And in fact, ISRO had already developed, space applications that had already developed two airborne scanners. One was a thermal scanner and the other one was a multispectral scanner. So this whole technology of the mirrors, of the rotating the mirrors, of the detectors, all these had been experimented with. So the idea was therefore to actually have in IRS a multispectral scanner, and perhaps again some sort of a Viricon camera, almost similar to what Landsat was. But there was a nice twist to that tale. And the twist was this: at that time, Spot was also coming up, and Spot people realized that if they want to get anywhere, they want to break away from the scanner kind of technology, and the CCD technology was coming up at that time. So they planned to create a satellite with the sensors with only CCDs. So they had a 20-meter resolution multispectral camera using CCDs, and a 10-meter resolution camera with which was panchromatic, that's normal black and white. So some of the engineers here, in fact particularly the person who was in charge of the development of sensors, Dr. George Joseph, he said that why not we try this out. So what they did was they first built a small camera which they put on an aircraft and flew it, and the results were good. So then they made a case that instead of putting a scanner which has a lot of mechanical components, and these could always lead to failure, why not we also go with a CCD? And that's how the first Indian remote sensing satellite, which was launched I think in 1981, carried a camera called the LIS. The LIS stood for Linear Imaging Self-Scanning device, and it had a 70-meter resolution. And in addition, they had two more cameras also using the same technology, which we call LIS2, which had 35-meter resolution. And the interesting thing was that these two cameras and the third camera, that's the LIS1 camera, they all looked at the same area. So in effect, you had a 70-meter image, and then that 70-meter image also was replicated in 35 meters using 4 frames of the LIS2. So this was a fantastic thing at that time, and perhaps apart from Spot, we were the only other country using CCD technology for doing remote sensing.
Yeah, that is actually a fascinating story in that sense as to how mature remote sensing was in India at a particular given point of time. You talked about analyzing data and so on. So today, of course, there's a lot of computer-aided GIS and data analytics tools that have been around. What was the early days of analyzing data, and what would what was the interface like, and how would people analyze data, especially given so much data spread over such large geographical area?
Yeah, that was very interesting, because in those days, you didn't have this kind of handy computers like like we have today. So the PDPs used to rule the computing world, and some people started trying to create a small image processing system around the PDP, and later on, of course, we went in for a bigger mainframe called the VAX 11780, but that's another part of the story. Most of the applications at that time were visual analysis. So they would look at the color, tone, texture, shape, context, and then interpret what they were seeing. So mainly we worked with actually either diapositives or prints, and you could enlarge these Landsat images and as well as list one images about 4 times. So essentially what you got was the original data would be 1 million scale, 1 is to 1 million. So expanded to what about 1 is to 250,000, and then they would actually either put the image on a light table, and on that they would put a tracing sheet, and then they would actually with a pencil trace out the features. And then we one of the things that we talked to some people in the optics industry, and they came out with what we call the large format optic enlarger, and that is an enlarger in which you could shove in a one of these huge diapositives. Those days the diapositives used to be about, I think, 8 by 8 inch, typically like the aerial photography frames. And then you could expand that and to about 4 times, and then again the same thing, put down a piece of tracing paper, and then with a pencil trace out the various features. And then of course the other great thing was, then you had to know what features you are tracing, so you did what is called this, the ground truth. So you went down to the field and you actually verified what was that feature. Parallelly, of course, as I said, we were doing a little bit of work on the digital data, because NASA was supplying us with both the print, the diapositives, as well as the digital data from the Landsat. So these were being used by the people, and image analysis as such was still limited to a few laboratories. Maybe Space Application Center was one of them, and the National Remote Sensing Center, which at that time was with the Department of Science and Technology. They were also using image analysis, but it had really not taken off at that point of time. It took off when we started with the IRS satellite data, because there, of course, digital data, we had both hard copies as well as digital data. And what we had done was, we had created 4 or 5 centers, which we called as the regional remote sensing service centers, which were equipped with the digital computers and image processing systems. And then these were then people could come there and use the digital data, do the image analysis, image enhancement, and all this kind of stuff. So that's how we tried to spread out the use of digital technology. But in my opinion, the real flip to digital image processing and use of satellite data in a digital form came once we had got the workstations, the Sun workstations, and then I think Apollo was another one, which you don't hear of much now. Silicon Graphics also was another one. And then, of course, came the PCs. And the powerful PCs, once they came out, they could very easily handle this kind of data, as well as the kind of software in fairly good speed. You could do for example, what we call the MXL analysis in about maybe one scene in about half an hour or so. So that's how the whole thing developed.
What was the early days like in terms of reaching out to some of the users? Of course, I would imagine that not many end users would know these possible applications that they could use.
Yeah, one of the features that in the Indian space program, the remote sensing program specifically, was that we were very conscious that this was not something that only ISRO can do, and therefore, actually, even before IRS-1A was launched, um, both Secretary DOS, that's Professor Dhawan, and Secretary DST, that's Professor MGK Menon, both of them got together and they formulated a program called the NNRMS, the National Natural Resources Management System. And they pulled in the planning commission, and the planning commission made a committee which is called as the preparatory committee of the NNRMS. And then each of the major user departments, like Department of Agriculture, Department of Steel and Mines, Department of Science and Technology, Geological Survey of India, all the agencies, the secretaries of these departments were part of the planning committee, and there were similar committees formed comprising of both ISRO people and the domain experts in each of these departments. And for 1 year, we conducted a lot of experiments with them. And these experiments was called the Joint Experiments Program. And the idea was twofold. One is basically to decide what would be the bands for the IRS, and the second was what could be the possible applications of the IRS. So all this was being done even before IRS was launched. And then before IRS was launched, we started planning for what we called as the IRS utilization program. And in that again the same thing was done, and that's basically our contacts which we had with all these people. We got together, and then we chalked out a program of how actually to use the satellite data for the various applications, and how to take things forward basically. And we saw that there were some people who were pretty advanced, like for example geological mapping, and then the semi-operational ones were where the people didn't have such a good grip, but still they knew how to do it. So for example land use mapping was one of them. Then you had the experimental ones where we had to try out a lot of stuff, and this was, for example, typically crop forecasting was one of them, but not really forecasting, but crop area detection and measurement. And the TDP kind of thing was crop yield modeling, which required a lot of on ground experimentation as well as experimentation with the satellite data. So this is the way we prepared, but the main point to stress is that we always carried the end user with us. We never did something and then waved it about and said, hey, look, what a great thing we have done. We always had the end users with us right from even before the satellite was launched.
Was there a lot of thought given into how will it scale nationwide? And, given that how diverse the country is and how diverse the user base can be?
Yeah, that was definitely a part of the planning, because as I said, one was that all the departments were involved, which was the central government. Also the state governments were involved, and we had set up 5 different centers for helping the states to get into this technology. And we had kept the centers in places like Jodhpur, and then Dehradun, then Kharagpur in the IIT campus, Nagpur, and in Bangalore. So these 5 centers were supposed to service the end users from the 5 regions. And as I had told before, that the NNRMS, we had started with the Joint Experiments Program, and then after that we had done the IRS Utilization Program, and the entire work of the IRS Utilization Program was getting done by these 5 centers, as well as the 2 centers, ISRO centers, that is Space Application Center and National Remote Sensing Center. So in the idea, of course, was that this was the way to go, and the states would need to pick up on each of these applications. So we also then started visiting each and every one of the states and encouraging them to set up their own centers, remote sensing centers. And this went on for quite some time, and finally I think we got almost every state in the country to set up their own remote sensing application centers, which now have become state space application centers, because they added the communication part of it also, because the communication was being used for the distance learning programs and things like that. But then I'm getting too far ahead in the story. So this was what was there, and the preparatory committee of the NNRMS was converted into what is called as the planning committee of the NNRMS. So the idea was that they would oversee how this technology was spreading into the all over the country. We also had exercises in trying to get educational institutions to also include these technologies as subjects in their course material. Some of them had already done it, like for example anybody who study geology would already have learnt about at least aerial photography, if not satellite image processing. But they started also formulating separate geospatial courses, like remote sensing and GIS courses were started off in so many institutions. I think how many, I don't remember now. Maybe around that time we counted something about 140 institutions which are having this kind of courses. So the if you see the effort, it was very much coordinated. You had the end user agencies very much in mind. uh, you had the education sector very much in mind, so that they would produce the people who would then staff many of these centers. And then ISRO had made a commitment that they would always continue to provide this kind of satellite services. So it was all very nicely put together. Did it succeed? Well, I think in part it did. For example, today you have the Malanovis Center in with the Ministry of Agriculture, which is basically carrying forward the crop production and estimation, yield estimation effects projects, which were started in IRS 1A, and which now they have operationalized it, and they've spread it to many more crops, including horticulture crops and so forth. So that is one big success story. Use of this technology for geological survey, for groundwater, definitely is very much being used. ONGC uses this technology very heavily. The point that I must say is that we were looking only at the government agencies. We really did not look at the private industry. I personally feel that that was a lacuna. What we were looking at the private industry was basically to provide services, or at the most provide some hardware. So, like, there was a large format optical enlarger which I talked about. So there was a company in Hyderabad which was licensed to produce these in large numbers. We prepared an image processing library, and we tried to interest some of the computer companies, like one was HCL and the other was a smaller company, I think Spec Systems, to take on this manufacturing of this hardware and software, because in those days the PC was not strong enough, was not powerful enough in terms of number crunching. So there was a separate hardware which you had to attach to the PC to be able to do the number crunching. These met with not very great success, because the industry, by the time the foreign companies had come out with much better stuff. As I told you, there were a lot of workstations going around, running Unix, and you could use them very nicely for this kind of work. But all these efforts were definitely put in. Some succeeded, some didn't. But I guess that is the way. I don't think we have made any great mistakes, except that we did not involve industry as much as we should have.
One of the interesting debates that you could also look at is actually the evolution of technology in terms of the different bands of interest in remote sensing. When you look at several other countries around the world, you see a lot of the bands maturing in terms of the technology investment. So, for example, let's look at SAR, for example, synthetic aperture radar. You look at the investment made in SAR technology in either US or Europe, it's at a very early stage. And in India, I think we were right with them in the optical bands through the last, until the last maybe 10 years or so. But then the evolution of other bands, like let's say SAR or so on, so they have taken significantly more amount of time to evolve in India as a outcome in remote sensing. Why do you think this gap came up?
I think this gap came up for two reasons. One was that the technology itself was very, very different from the optical technology. The other was we are not very sure how much of it we could really put into the applications areas. Actually, we had started with the SAR a long time ago. In fact, one of the things that we were doing, I remember we had first made a airborne, side-looking airborne radar, which didn't have the capability of synthesizing the aperture. But nevertheless, it gave a jolly good amount of data which people could use. But then you had to understand what that data was. It was much easier to understand optical data, because it's more or less like a photograph. Whereas SLAR data, the side-looking airborne radar data, was not like was not like that. For example, if you had a water body and the water body was agitated, it would look like a field. Whereas if you had a water body which was very quiet, it would look like a water body, right? Because no signal would come back to you. So these kind of technological difficulties were there, and of course the SLAR was too primitive an instrument. We then moved on to the SAR, and that again we prepared a airborne version, which is still operational, and we did use it. But then flying a SAR is quite a job, much more difficult than flying just cameras or something like that. And then translating that technology to the to the space, that involved a huge amount of technology mastering, and we could do it ultimately with RESAT, and RESAT was a success to some extent. But then again there was a hiatus, because again the problem was we really did not get that kind of response on the use of SAR data. But as you see, the way the things have evolved now, it's really the military part of it which is really picked up, and perhaps that's the way it should be. So the current one which was launched a few days ago, I mean that's I think pretty state of the art.
When you look at the resolutions and the bands and so on, so and the map that to the current state of the art technologies, at least on the civilian bit, I think ISRO's capability and technology were on par almost until the year 2000 and so, and then there was some divergence after that, and then now they're kind of catching up in terms of civilian optical resolutions. How did the gap come up? And
I think the gap really was because of the regulations. Initially we were not allowed even to share the the pan data from IRS 1C 1D, which was about 8 or 9 meter resolution, and black and white, not even multispectral. We were not allowed to share that with the public. It had to go through a process of checking by the military and so forth, and therefore that kind of it slowed down the application of this high resolution data. Technologically we were there, we could have actually launched the high resolution satellites way back. In fact, I was discussing this many years ago. I was discussing this with Kiran Kumar, and he said that we are ready with the technology, but the problem is we need a go ahead, and that's where the problem came. Finally, it evolved into what is called as the TES, Technology Evaluation Satellite. It was called. That was one of the high resolution satellites, and we were getting resolutions, close to a meter from that one. And then, of course, we went into Cartosats. Cartosat 1 was 2.5 meters, Cartosat 2 was 1 meter, and then so forth. Luckily, they have changed the regulation, and now up to and including 1 meter is cleared. So that doesn't have to go through the defense mechanism. It can be sold to the public directly. But so therefore Cartosat 2, Cartosat 1 data is now should be freely available. But then again there is a hitch. What is the hitch? The hitch is that because Cartosat 1 is a stereoscopic satellite, so you can create a digital elevation model. But digital elevation models are by regulation cannot be shared. So these kind of regulatory issues are really killing the technology rather than anything else. As far as technology is concerned, we are really up there.
when you look at again, the end user perspective, to 1999 2000 is when the big military standoff between India and Pakistan happened in Kargil. I was thinking that one of the primary uses of remote sensing in its early days, of course, was purely military. Why did it take so long for the Indian military or somebody to say we need more satellites and more high resolution satellites, and especially a very big awakening after an incident like Kargil and not before that?
Oh no, the awakening was much earlier, much earlier. In fact, we were training people from the defense services to set up what is now known as the DIPAC. But we were training them, and not only in satellite remote sensing, but also in communications, intelligence, and so forth. So it was very much there, and I believe that they also had access to a lot of high resolution data, not necessarily from India.
So one of the interesting aspects of what is happening today is the total change from government to private actors around the world. And in fact, a lot of the private actors having more assets in space and remote sensing than the government assets themselves. I guess nobody saw this coming in any institutional level and any governments around the world maybe 20, 30 years ago, right?
Yeah, that's true. But we were working with the, for example, after we successfully launched IRS 1A, 1B, actually we went into a tie-up with EOSat. That was the company, I think it was Lockheed Martin and one more company, and they had set up this company called EOSat, and they were going to come up with a 1 meter resolution satellite. And they were interested in marketing our satellite data. And actually, what they had was they had a huge, menu card, starting with the aerial data, and then their high resolution data, and then the Indian satellite data, and then going on to Landsat and so forth. So, we were working with them, right? I don't know how far back. Yeah. Antrix actually, when it was started, one of the first things that they did, my friend Sampath was there at that time as executive director, and the tie-up with the EOSat for marketing of Indian remote sensing satellite data was one of the big things that had happened. And of course, EOSat got bought up by uh, Space Imaging. The connection still continued. In fact, our image processing. I mean, the basic data processing software which we had developed for IRS, we had gone and installed that in so many earth stations all over the world. For example, we had definitely, as part of the EOSat agreement, we had installed it in Denver in their earth station. We installed it in Japan. All 5, 6 countries were receiving data directly from Indian remote sensing satellites. So we did have this idea that the private industry would be coming in a big way, but in India it was not the case. We did not foresee an Indian company launching a satellite for remote sensing, from Indian soil. Uh, that has not as yet happened.
What do you think about actually the downstream segment? Because of course, launching a satellite is very challenging, and you need to have a lot of money and a lot of technical know-how and so on. But how enabled does the Indian geospatial industry on the downstream stand in terms of technological prowess, in terms of using satellite data, or even exporting services based on satellite data?
Oh yeah, of course. Exporting has been going on for a very long time. I mean, if you take companies like Spec Systems, or even what is now known as Scient. Earlier, I don't remember what it was called. Mohan Reddy's company, RMSI, Tata Consultancy. All these people were doing a lot of offshore work. In fact, there was a very interesting item which appeared in an Australian geospatial magazine, which said that if India concentrates all its efforts on its own data and does not do the work for the outsourcing, then the outsourcing people would be in sore straits because they would not get the information that they needed. So this was the kind of involvement of Indian industry in outsourcing. And today, what I find is that the Indian industry is doing extremely well as far as applications are concerned, and they're doing it independent of, ISRO. And unfortunately, independent of ISRO means they're not using ISRO data. They are using Sentinel data. They are using Landsat data. They're not using ISRO data for. I mean, it's the cost or the delays in delivery or whatever may be the reason. When I talk to a lot of my friends in NewSpace, they just give me a smile. So I think that's one area where ISRO is failed. But as far as the Indian industry is concerned, I have high hopes, and they're doing very well. They're doing very well, both offshore and now within the country.
Yeah, that's an interesting point, because you talked a lot about keeping up with technology and keeping up with end users and a lot of these things. I fail to understand why we could not replicate a lot of the open data models that were either in Landsat or even with Copernicus in Europe. Why was this lacuna coming up in terms of data distribution and making the data available to the public in India?
I really don't understand it. In fact, even when I was in ISRO, one of the things that I kept telling is that, why are we collecting data using the taxpayers' money and then telling the taxpayer you have to pay for the data? I mean, this is not fair. You need to make it free, if not free, at least very, very cheap. But they have done some things like, if the data is more than a year old, then it is priced at half the price. Of course, now you have Bhuvan. Bhuvan also allows some amount of data downloading, but these are not uh, sufficient efforts. I find a lot of education institutions, after I retired, I was teaching in 2, 3 places, and everywhere, the cry was, where is the data? Where is the data? And now they have found Landsat and Copernicus, and they are happy. They don't bother. So, at this level where the students are beginning to use remote sensing in their projects, and then they go to Copernicus or to Landsat and they ignore IRS. Why? Because the data is not easily available. I mean, why will a student who has a limited amount of time waste his time in collecting data when he can get it much more easily from other sources? So it's inexplicable. I don't understand it. I've spoken about it, written about it. I guess I don't make much of a impact.
Is this something a policy decision of ISRO or something that the government of India outside of ISRO has to take to make such changes?
My personal opinion is that ISRO can take a decision. After all, the remote sensing data policy, ISRO only formulated it. Yeah, you had to get it through cabinet, but that's not such a difficult thing to do. Making the data free should not be such an important decision. It can be done. I don't know why they are not doing it. You see, how it started was in the good old days when the National Remote Sensing Center was, receiving Landsat data and then IRS data, and then they were processing it, and they were a grant-in-aid institution to the Department of Space. So they said that we need to be self-sufficient, so we're going to charge for the data. And of course, then they were limited to charging only for the actuals, which means basically the what you have put out of your pocket. But it was not economical, because being a semi-government organization and now it's a fully government organization, they are overstaffed. So how will they even recover any cost? They don't recover any cost, but still they go on charging. I just fail to understand this. One of my persons who had gone abroad to install the data processing software for IRS in one of the European stations, he came back and told me that, sir, they have just 4 people operating the entire system, the data reception, the data processing, everything they're handling with 4 people. But that is what, if it goes into private industry, that can happen. We most probably have about 40 people doing the same thing. So where is how do you recover the cost? You just can't recover the cost. And now I realize, once it has become a national remote sensing center, it's totally a part of ISRO. So it's totally being funded by ISRO. So where is the cost? Where is the question of cost recovery? It's all taxpayers' money. Make it free.
You already talked about Bhuvan and that being the geospatial portal, and satellite data from India being made available there. There's a lot of efforts across the world that are independent. So Landsat has its own efforts. Europe has Copernicus. India has Bhuvan and in its own IRS program, and the Chinese have some. The Japanese have some. There has never been an effort of consolidating all data sources into one single global repository, right?
Yeah, it's never been done. At the most, what was tried was, first you had the CEOS, the Committee on Earth Observation Systems, which basically tried to standardize on the technical part of it. And then now you have GEO, a group on Earth observation. They're also trying to do that, and they are also basically, it was Barbara Ryan who started the whole thing, particularly with Landsat, and she has been pushing. Of course, she's no longer with GEO now, but she's been pushing for people to come and share data. And I don't see much of any sharing that is really happening other than Landsat and Copernicus. Indian data, they say Bhuvan, and you can take it from Bhuvan, but Bhuvan is so slow. And why is Bhuvan slow? Because government of India says don't put this data on the cloud. So it's all on a set of servers in India, and our connectivity, as you know, is not all that great. So even within India, people find it difficult to download the data. So leave alone anybody from outside. So there are again these kind of silly issues which are holding us back. But what your question of putting everything together globally is something that I was thinking that perhaps the UNGGIM would do that, but no, they are not addressing that issue either. So I'm not very sure whether it can ever take off. On the weather side, I think they have. On the weather data, that's the meteorological data, I think there is a common resource, uh, global resource which people can access. But on the remote sensing, that is this kind of land remote sensing, I have not seen any attempt to put it together.
Yeah, so the only other one that I can recall is the UN Spider, which is for the disaster management system and requesting imagery for disaster areas.
Yeah,
When
yeah.
you look at a lot of the end user applications today, one of the key things that is available to an end user is a smartphone. And the legacy applications that are built for geospatial, they were not really directly end user focused. So let's take an example. For example, the ISRO application with the Fisheries Survey of India of trying to provide the potential fishing zones. It's an excellent application in terms of how the data is collected and how the usefulness for the fishing community and so on. But for example, today there is a smartphone where you don't need to then use a middleman in the process, which is the Fisheries Survey of India, who then have to then transmit the data or have that sent to the end user. You have today the smartphone, which is directly available potentially to many of the people, to get that as a direct G2C or government to citizen application. Why do we not see a lot of this architecture of geospatial applications today in many of the ISRO programs?
ISRO programs, yes. Well, they do have a Bhuvan on the smartphone. If if you want to know, they have Bhuvan on smartphone. So in principle, whatever you can do on the desktop, you can also do on a smartphone. But that's not really the issue. The real issue is, you need to get data into the hands of the real end user, and the real end user is not another government department. The real end user is the man on the street or in the field. You know, so you have to make your applications that simple, where any person with a smartphone or maybe a tablet can actually access the data from the portal, use it to get the answers to whatever questions he has, and then go ahead and apply it. I don't think that Bhuvan even reached or even made an attempt to reach at that level of application. I recently, if you are aware, if there was a portal which was launched called India Observatory. This was launched by a NGO called Foundation for Ecological Security, and they are doing precisely this. They have little apps on that, and the end user, if he has a tablet, he can download that app, and then he can have things like find out from his field what are the problems that he has in the field, or what he would like to plant there, whether that will survive or not. This little app that they have. Similarly, they have apps which tells them what are the government facilities that are there, or programs that are there which they can avail of. These are two of the apps I know, and they're adding many more apps as they go on. But this is essentially the effort by a NGO, and made open very recently. In fact, it was done only this month itself. I think 20th of December it went online. You can have a look at it. It's very interesting. Just go for www.indiaobservatory.org. So these kind of efforts now are coming up independent of the government. But of course, they have to follow the government laws. So they can't put high resolution satellite data. They can't even share, for example, data from Survey of India, though they are using it in the application, but they can't put it online. They have recently got permission from the Registrar General of India to put the census data online, so they are now happy to be able to do that. I personally believe that the time for government doing all these things is all now gone. Now it has to be done at the level of the private industry, or at least the NGOs, and the target cannot be another government department. The target has to be the man on the ground.
Yeah, that's pretty interesting because when you look at a lot of the new frameworks that, for example, here in Europe, people are thinking about is calculating very strongly possible metrics on return on investment in especially the whole remote sensing realm. And there's been multiple studies that I see right now that are looking at what is the return on investment on Copernicus. And one of the surveys that I came across said that almost 50% people reported that they will not use, not pay for remote sensing data, and will stop generating that application if Copernicus data was not available for free. It's a staggering number when you think about it, that 50% or more than 50% of the people will give up providing a particular service if the data is not available for free. And the other bit is, of course, there's not really any kind of open data available on the metrics of usage of remote sensing data in India, and how ISRO data is being used, and what is the return on investment on any of this kind of information, right?
Yeah, there's some studies are there. Rather than now they are dated, but there are studies there. I know one study which was done by ISRO itself, Y.S. Rajan Chandrasekhar, and I think Gopal from the Hindu. And one more study which was done by a professor in IIT in Madras University. There is a huge amount of benefit coming out, but the benefit that comes out is more from the new applications than from just replacing the old applications. I have myself done a study in which I have shown that using the data from these two studies, that if you are selling the data, then you are not even breaking even. If you are selling the data plus you look at the immediate applications which are there, then you just about break even. But the real power of the data comes when you bring in new applications, and I think this is the lesson. And what the European study is saying, that if you don't if you start charging us for Sentinel, we will not do remote sensing. That's precisely it brings out the same point, that the data must be free and open. Both things are there. And because the amount of effort that a person has to spend in terms of using the data itself has a cost which nobody seems to look at.
There's two big things that are coming into remote sensing. One is, of course, the cloud and integration of the cloud, and second is all the machine learning and AI and all the other fancy things. Are we keeping up on this? Because currently I don't see much of cloud integration into ISRO data, or even haven't read any new papers that look at focusing on machine learning or AI in terms of applications.
For one thing, as far as the cloud is concerned, as I told you, there is a policy issue. The government data can be put on the cloud, which with all this now data localization and all that what you're talking about, it's going to be more and more difficult. Because they treat the geospatial data as something very secret and things like that, and so long as you do that, you can't put it on the cloud, and that's how Bhuvan does not go on the cloud. It can very much go, but it doesn't go. One possibility is, okay, if somebody like NIC comes out with a Indian cloud offering, and then whether we can use that, but that we have to see as it evolves. As far as the use of AI, big data analytics and all, again, what you have concluded is what I have also concluded. As far as ISRO is concerned, I'm not seeing them using these new technologies at all. I have quizzed many people, but I don't see any. For example, you take this whole business of the crop forecasting, right? This is actually something that which is demanding, crying out for application of big data analytics. But I haven't seen this being done. In fact, I was talking to the director of the Mahalanobis Center also. I didn't get a clear image of what way they are also thinking in terms of these technologies. So yes, we are far behind on this.
The other interesting aspect is now you have some of these new space startups in India that is also planning to do remote sensing in terms of upstream, as in a combination of having their own satellites and also processing it on the ground. Do you think we have the necessary policy framework for them to be operational in India?
No, I think until and unless the Space Act comes in, I don't think this. I don't see this happening at all. And the Space Act is being delayed and delayed and delayed. What is the new version of the Space Act is something even I don't know. I had got an old version. I had made the comments on that also, but after that, I don't know what's the new act. So until the Space Act comes into play and is, uh, friendly towards these kind of private ventures, I do not see this happening very soon. But on downstream, I do see NewSpace doing a lot of good work, a lot of good work. And in my opinion, they have really overtaken whatever ISRO is doing now.
So if you, let's say, in a situation where some of these new space actors that are up and coming started flying these satellites and started using this data, and the Space Act is not yet there, what could be the repercussions for them? Would you think that most of these companies would then be going to countries like Singapore or US and setting up their bases there, but then just doing end user services in India based on a cloud, or will they circumvent the whole route?
This is what normally happens. If you recall, the whole business of satellite broadcasting, the private companies initially, they were creating videotapes and then, supplying those videotapes to us. Then they went off to Singapore and they were uploading from Singapore. It's only after the rules changed in India that they now upload from here. I see the same thing happening in remote sensing. I already, in fact, you are also aware. It's much easier to set up a company in Singapore or London or wherever you are, because they are much more user friendly and much more business friendly than our Indian rules. So this is going to happen. This is going to happen.
One of the more interesting things is actually the whole integration of geospatial into the whole Chinese foreign policy and Chinese military as well. Especially like the Belt and Road Initiative is one thing where you're thinking about an entire geospatial corridor in itself, where all the Belt and Road countries can potentially start using geospatial applications.
Yes, that's a fantastic effort. You may not like it, but the way they are doing it is fantastic. On the other hand, you look at our efforts in the SARC satellite, for example. Have you heard of any country which is using the SARC satellite? I don't see anybody using any SARC satellite.
It is especially interesting because I think, given that the Chinese made this move, I think recently even the Japanese came up with this proposal of having a central repository of imagery, and they even made a certain announcement that even state-of-the-art satellites like the ALOS data will be now made available for free. So you can see a lot of even other countries in the neighborhood who are keeping up with the developments in China, basically coming up with their own changes and policy prerogatives for that. And even I think now China has also increased the resolution to 0.5 meters. And in India, we still have 1 meter resolution.
Yeah, I mean, again, the same problem. What I see is a regulation which is acting as a big, bump on the road. Actually, we are producing data which is at centimeter level, but the civilians can't access it. It's only meant for the military.
So, do you think we talked a little bit about the Space Act? The Space Act was not comprehensive at all in any sense. In that, it was I think the Space Act would have been a great opportunity to consolidate a lot of different things that is in communication, in remote sensing, in navigation, and so on. But then it did not really, address anything in a very detailed manner. Do you think the Space Act should have been something that were chapter by chapter addressing each and every particular aspect of space, and then could have gone into a lot of the geospatial domain and addressed all of this kind of information, these kind of things that are needed for giving an impetus for the data use in India.
Yeah, I think so. That's one of the problems with the Space Act, which I saw was, they tried to make it all encompassing. You also talked about these launchers, you also talked about satellites, you also talked about applications. The whole thing was very confused. And one of the things which I feel they should have done is that should have broken it up into specific segments. So you have one overall segment, whether we are doing a launcher or a satellite or an application, you have a kind of common set of rules, and then for each of these areas they should have formulated different rules, and the same thing they should have done for the geospatial. There is a very interesting document which was produced by a think tank, which was, I think, chaired by Mohan Reddy, and it was started by my friend Sanjay Kumar from Geospatial Media. And this think tank came out with a very comprehensive document on geospatial for the new India. That's what it's called. But there again, if you see, is they have identified the problems and everything, and how geospatial can help. But in terms of implementation, the only thing they have said is that there should be an apex committee which should be part of either Niti Ayog or PMO's office, and which should have people from both government and industry and so forth. And then, almost as an afterthought, regulation wise, they said 1 meter data should be made free. Free to deliver, which it already is. And I think map data, 1:25,000 scale map data should also be made free, which is neither here nor there, because even if it is made freely available, the coastal areas and international boundary areas will still be remaining out of the reach of common persons. Frankly speaking, I'm a bit pessimistic about this whole thing that is happening. I don't see anything great happening. It'll be kind of incremental stuff. Okay, so earlier 1 meter data was not free. Now 1 meter data has been freed, but half-meter data is not free. Oh, then maybe somebody will come up and say, okay, half-meter data is also free, but 25 centimeter data is not free. This kind of small linear progression is not going to result in any kind of breakthrough.
So where do you see the future ahead? What would you see 10 years from now? How would you compare an Indian ecosystem versus a European or a Japanese or a Chinese ecosystem?
Very difficult question to answer. I'm not very hopeful. I'm not very hopeful at all. I think we could have done much, much more with the kind of infrastructure that we have, and with the kind of systems that we had set up. We should have been as good, if not better, than China. Today, we seem to have missed the bus, and I don't see anything great happening in the next 10 years. Yeah, you will make a lot of satellites. They'll be used by the military forces. Maybe some civilian use also will be there. You may have a few more centers coming up, like the Mahalanobis Center in Ministry of Agriculture. You may have a few more centers coming up. But I really don't see any great breakthroughs happening unless, as I said, people take the bull by the horns and say, okay, this is what needs to be done.
Let's end this episode on a potentially high note. What would you think is the recipe ahead in terms of changes? What would you say are the top changes that need to be done for everything to open up in the future?
These limitation on the data, particularly on the remote sensing data, limitation on the map data, these have to go. You protect yourself in other ways, but you cannot simply protect yourself by denying. Denial is no kind of protection, in my opinion. So that once the regulatory framework gets set up, and then, as I said, the Space Act should get set up, then we will see definitely a huge amount of interest coming up, not from the government, but more from the private industry. And I believe the private industry is raring to go. all that they have, all these little problems which they have with the regulations, the way of setting up these companies, all these issues relating to uh, having the company in India or not in India, all these things, if they are addressed head on, then the things will improve. Geospatial will become a, a bigger part of our lives than they are today. I mean, today, people use Google. I mean, without thinking, they use Google. If so, therefore, people are not illiterate in that sense. They understand geospatial. All you need to do is basically make applications which are people oriented, and definitely it will work. I am reminded of a saying by CK Prahlad, the management guru. He used to say, address the lowest part of the pyramid, common people, the farmers, the people working on the land, working in the water. Address them, address their needs, and you will find that there is huge amount of profit in that. And that's what geospatial, if it has to go forward, that's the market that they have to address. If you do that, then perhaps India will once again show the way to the rest of the world.
It's been really insightful learning a lot of things, and I hope the audience enjoys as much as I did. Thank you very much, Arup, for your time.
Thank you, Naran. Thanks very much for this opportunity.
Thank you for staying until the end. If you have any comments or suggestions, please write to curator@newspaceindia.com. Please consider sharing this episode with any friends or family who may be interested in learning about India's space activities. If you would like to stay in touch with the NewSpace India community, please use the link in the description to join the NewSpace India Telegram group. Feel free to also suggest guests for any future episodes. A new episode of the NewSpace India podcast is released every other Friday. Do subscribe to the podcast using Apple, Google, or any other podcasting platforms you may use. Until the next episode, thank you.